Hello, today start with our DSA with this amazing visualizer by dsa.chaicode.com by ChaiCode. So go to this link, use this link to get a 7-day free trial. Okay, let's start with today's question, and today's is product of array except self. Okay, so given an integer array, return an array where output I equal to the product of every element except array of I. Solve it is big of in time without any extra. Okay, so the question state, so suppose this is our array and the output should be, okay, let's draw the output. What it takes, return the array of output I equals to the product of every element except array of I. Okay, so first go to index 0. So 1 at index 0. Except this index 0, multiply everyone, like 2 into 3 into 4. So 6 into 4, 24. So it will be 24. Go to the next index. The index 1. Okay, so without 2, multiply all, 3 into 4 into 1, that's mean 12. Now again go to next index, this is 3. Without 3, multiply everyone, like now so 4 into 2 into 1, 8. Okay, so for the last index, the 4 is here. So except 4, multiply everything, 3 into 2 into 1, that is 6. So this is our answer, 24, 12, 8, 6. So take one element and except that element, multiply everything inside the array and put it into the index of the same here. This is our index 0, this is index 0. So multiply these three element and put into the 0th index. Okay, so first, how could we actually achieve it? Before going to there is, just go here, just use two loops. Two loops. First loop is I, then the second loop is J. Okay, so take, we can use a two pointer approach here, like first loop start from here, also the J loop start from here. When the I always equal to J, we just reduce, or we just remove that element, or just we don't see that element, we don't multiply that element. This is what we will achieve. We need two loops here. So first loop is pointing towards the element itself. If the second element is also pointing to the same element as I, it always remove or ignore that element. So for the 0th index, the I is at 1, the J is at also at 1. So the J start from 0, but whenever it got this I and J at the same index, we just ignore that index. We just ignore that index and multiply rest of them. Okay, so we can use a tool of and use it. Let's first write the pseudocode here, or let's first see the visualization. So so okay, let me reduce it. So for the first index, for the array of 0, multiply every element array of 0 except 1. That's mean 2 into 3 into 4, that is 24. Okay. For the next element, multiply everything 1 into 3 into 4, but not 2. For the next element, multiply everything 2 into 1 into 4, but not 3. For the next index, multiply everything 1 into 2 into 3, but not the fourth. Okay, so this is our output array, and this is our output array, both are same. So using two loops we can achieve that. So the code will be very simple. So if we take a function which take an array, first take an answer, which is an empty array, answer or output, empty array of the same size, obviously, and now traverse a loop from start to end. Okay, so inside here we just take one variable, that is multiply, and just point the multiplication from point the all the multiplication that we store should be stored into this multiply variable. So j also start from 0. Why start from 0? By chance, in any case, in the case I is here, so we just have to remove this 2. We just have to remove this 2 from the multiplication. Rest of 3 will remaining. If we put j like here or maybe here, then we just miss this one. Here it is 1, maybe someplace it is 2 or 3. Then the multiplication will not be valid. So every time I started from which place in the array doesn't matter. J should always started from the starting, because we have to take every element except that one element, that is the index I. Okay, so from 0 to n minus 1, if I equal to j, if this thing comes that I and j same, when this is the condition, we just have to ignore this. How can you ignore this? Just continue it, just continue it, just continue it, and if I and j is not equal, just multiply it into the multiplication. So the multiplication would become multiplication into that element. Okay, so and put the multiplication and the ith index. Okay, because I store the index of the input array, so at the end return answer. Okay, why we put it here in I? So let's suppose I is here. Okay, we start j from here, we multiplication all of this except this, but now we have to put the value to an index. In which index? In the same index of I, because we are at this index I. So this should work. Evaluate. Okay. Inner loop correctly oh, sorry. Okay. So in the inner loop, we should multiply with j. Oh, why j? Because j is starting from here and goes to every index. So whenever we just put this index, which is I and j are equal, we just ignore that index. Okay. So this should be j. Okay, we nailed it. Now let's go to the solution and write the code for here. Although it will not work, but we should write it. So first take the size of the nums dot size. Okay. Now just put all the values into the num. So take a vector of int of answer of size n. The size should be equal. Then just run a for loop for int I equal to 0, I less than n, I plus plus. Then inside the for loop, take a variable multiplication. Every time it started from 1, because it is a multiplication, and 1 into any number is that number. So start the j loop from 0 to the end, j plus plus. uh, and every just check this condition. If I and j are at the same index, just ignore this index, just ignore this index. Okay, is just multiplication it with the uh, index of j. Why? Because j traverses the whole array. Okay, and we just reduce that I only, or ignore that I only. So at the end here, after completing the j loop, let's put I into the multiplication should be inside this. Okay, and after this just return the answer. It's working. It should give a TLE because it uses two loop, and two loops are like starting from the end, so there is a big O of n squared time complexity, and we use a space of big O of n, but we just returning the space, so we can consider it or we can remove it as you wish. But it's it's actually good to consider this because we use this space to solve this question actually, because we need to put the answer into it. So there are two loops, a start from starting to end. It just goes and goes and goes. So big O of n square, or big O of one space you can consider. No worries. Now prefix and suffix approach. Okay. So in this approach, what we will be doing at, we take two values. Okay. We will take two values. One is a prefix, another one is a suffix. Okay, and the prefix will start from 1, and every time we add the prefix till that index, or obviously removing that index, and just add the value to the output or multiply it. Okay, so you can clearly see here, like split the product of output of I is everything is left of I and everything is right of I. We just multiplication both. Okay, so in this case, if we got the I, if the I is here, the value of the output of this I index is everything from this side and everything from this side, and multiplying both of the side. Okay, to ensure this multiplication of both of the side, we are using two loops here also, but in a different way. Here we are using two variables. One is for prefix to calculate prefix, and another one is to suffix to calculate suffix. Okay, so first in the first part, we just initialize a prefix that is 1. Now we just take the output array and add the prefix to that index. Okay, we just add the prefix to that index. Prefix is 1, so in the 0th index we add 1. 0th index we add 1. Okay, similarly in the new case, what we will do, now we have to increase the prefix. How we increase the prefix? Multiply this array of I or array of 0 into the prefix. Okay, so prefix of left is 1. Okay, now the prefix is again 1. Why 1? Because the previously 1 into 1, so it's again 1. Okay, but now we have to perform this line, which is prefix equal to prefix into array of I. In this case, the next the prefix value will become 2, but for the next index we will increase it at 2. Okay, so here is 3. Similar for prefix, we just multiply it with this and we get 6. Now from the left, from the right, traverse towards the left, from just a reverse traversal. At the last index, take similar like suffix and add the suffix to the output, and here we just multiply it to the output, not just simply put it to the output, because we need prefixes also. Next we just multiply the suffix, and the suffix multiplication is same as prefix multiplication, just add that element. Okay, we just add element. Let me draw it here. Okay, so we are given an, so this is our array. So this is our array. So first we have to take an output array of the same size. We take an output array of the same size. Okay. At the first step, take a prefix value that is 1. So prefix will become 1. Now go to this index 1. Similarly of this output index. First in the output, first step in the output, put this p value to the output that is 1. Okay. Now multiply this array of I value into p. So 1 multiplication 1, it will become 2. Okay. Go to the next index 2. In the 2, first insert the value of p, that is 2. Now, oh, sorry, this is not 2, this is 1. 1 into 1, 1. First add the value 1 here. Okay, in this second index, and multiplication 2 into the prefix. We just multiply 2 here and we get the prefix of answer 2. Okay, go to the next index. First put the prefix value. We just put the prefix value. Now multiplication it with 3. We just need to reduce it a bit. So it will become 2. Then we multiply with it 3 and it become 6. Okay. Now just go to 4. 4, put the p value that is 6 and multiply it with the value that is 4 and we get 24. Don't put this value here. Now similar like p, the value, the work of p is done. Similar like p, we have to traverse the array from the end also. Okay, just to remove this. Okay, okay. So now we have to traverse the array from the end. From the end, that means we need a suffix. So suffix at the starting became 1. Okay. So now we just don't replace it with suffix. Previously we just put the value. Now we just multiply the value, like it will be 6 into 1 and the value will become 6. 6 into 1, the value will become 6 for the last index. And also into the suffix add the, multiply this 4 and it will become 4. Now go to previous. Now in the here multiply it with 4. When you multiply it will become 8. The value become 8 and multiply this 4 with this 3 because we are at this second last index. Okay, so it will become 12. Now one step down. In this 1 multiply with the suffix and the current suffix value is 12. So just multiply it 12 and get 12 here. Okay, and multiply this 12 into 2, that is 24. Okay, now came to the first index and multiply it with 24. And when you multiply this 1 with 24, the answer will become 24. And if you notice, this is our answer. So what we are actually doing here, we take a first prefix, and for every step we just first put the prefix value. Like for this step 2, we multiply everything till this step and put the value into this index, and the value is 1, because okay, this is 1, this is 1. So multiply everything from the prefix till that index, not including that index, and put it into the same index here. That is 1 at the starting, if you remember, that is 1. And again, when we are actually traversing from the end, we are just want to multiply this suffix type. So suffix means multiplication till this type. So 3 into 4. We ensure this here, the 12. And we just multiply these two values, this 1 and this 12 here, and we get this 12. So in this approach, we just find the multiplication of the prefix, multiplication of the suffix, and then multiplication both of them into a single array. Okay, we don't use any extra space, we just need only one array to just return the answer. And we are actually using two loops, so it will be big O of 2n, not big O of n square. It is very convenient. Now just write the pseudocode. So first write a function array. We can answer that is an empty array. Take the prefix value at the starting, that is 1, and do a for loop starting from 0 to the end, and add everything to the answer. Just put everything to the answer of I will become the prefix value, and add the answer of I to the prefix value for the next index. So the prefix will, will become the prefix into array of I. Okay, so this will become our prefix. Now take a suffix, the loop to traverse from the end to start, that is a suffix starting from the end. Take a j loop from n minus 1 to 1. Inside this j loop, just put answer of j is become answer of j in that index, whichever the value get, that is the value from the prefix. Now we need to multiply the value, not addition, multiplication the value from the suffix. So we add the suffix here, or multiply the suffix here. And also for the next index, we have to increase our suffix. The suffix will become suffix into array of j, and at the end just return the answer. Okay, 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 it should be 0, it should be 0. And rather than everything, answer in prefix into array of I, prefix into array of j, answer of j into my suffix equal to prefix. Okay, let's do this. Okay, we nailed it. Just go to the question and now try the optimize approach here. Optimize approach. Let's So this is our approach. First take the size that is nums dot size, take an answer of that same size. Okay, so take a prefix starting from 1. So a for loop for int I equal to 0, I less than in I plus plus. For every loop, answer of I became prefix, and the prefix will become prefix into nums of I. Similarly, take a suffix int suffix equal to 1 for int j starting from n minus 1, j is greater than equal to 0, j plus plus j minus minus. Okay, minus minus, and just take answer of j will become answer of j into nums of, I'm sorry, into suffix, and the suffix will become suffix into nums of j. Okay, now at the end just return the answer. Just submit it. Yes, it's working, properly working. And it just take two loops, one for loop from start to end, another for loop from end to start. The time complexity will become big of n, and we just use one space, but this is only for to return the answer, so we can consider big O of 1 as space complexity. Okay, also mentioning here. Thank you for watching this. Use this link to get a 7-day free trial. Use this link. Okay, thank you very much.